Hey all, welcome to another episode of AI Safari. Today we're going to discuss a bit about data processing units, also known as DPUs, what they are and how they're being used to streamline CPU performance and other workloads they support. Garth Fruge, DPU Segment Lead with NVIDIA for the Americas, is here to help make us all DPU experts. Okay, maybe not experts, but how about just make us more knowledgeable? But before we get started, can you, Garth, tell us a little bit about yourself?
Yeah, hey, I appreciate the invite. Happy to be here talking about DPUs. As you said, I'm with NVIDIA, and I am the DPU Sales Segment Lead for the Americas. And I'm here at NVIDIA by way of the Mellanox acquisition. And yeah, like I said, happy to be here. I kind of live, breathe this emerging DPU space. So excited to talk about it.
Fantastic. Okay. So Garth, DPUs are increasingly being considered, I guess, to be the new computing platform that's supposed to improve CPU efficiency and also improve the ability to move data around the data center for workloads like AI, which I'm passionate about, as well as simulation. We're all familiar with CPUs, so general purpose computing, and GPUs, of course, which have rapidly moved from, originally purely graphics utilization to key enablers in machine learning and deep learning applications, I guess really considered a CPU offload for the more complex parallel computations. So for those who aren't familiar with DPUs, can you explain what a DPU is? And what are the drivers behind the need for this type of microprocessor?
Yeah, that's a good place to start. So, you'd mentioned it, but, let's start with the acronym, right? A DPU is a data processing unit. And, you'll hear us describe it as a domain-specific processor optimized for data movement. And I like that one. You guys have probably heard me use that one. You'll also hear us reference it, as you said, as this new enterprise compute element, right? Joining the ranks of the CPU and the GPU. And it's really designed precisely to offload, accelerate, and isolate, those data center infrastructure services. So I'm talking about things like networking, storage, security, those data center services associated with the infrastructure. Mm-hmm. I think just yesterday I was on a call and I heard someone describe it as an accelerator with network ports. And I like that one too. I think it had some interesting implications with that one. But yeah, that's kind of it, sort of the broad brush stroke.
Is it like a mini server within a server? Is that too much of a stretch?
It's exactly what it is. And it's really what kind of differentiates a DPU from, a traditional NIC or traditional smart NIC, in that, you've got something here where you're not just accelerating the data path, you're not just accelerating the data plane, but you're able to leverage these general purpose compute resources, which is running its own operating system. It could actually offload the control plane policies, in addition to accelerating the data plane, and bring with it advanced security services. So it's a great way to think about it, where you're putting a server kind of within or in front of a server.
And so, I mean, maybe you touched on that, but are there significant drivers that are the reason for this new microprocessor?
Yeah, I mean, I didn't touch on it, so thanks for bringing me back to that. We like to talk about this data center evolution. And when we talk about the evolution from dedicated hardware appliances to today's, let's call it, software-defined data center. And, here you've got your CPUs hosting, maybe bare metal, maybe hosting virtual machines, containers, but this is where you're running those business applications. And you've got your server configured with the NIC, whose role in life is to send and receive packets really as efficiently as possible. And that area in between that CPU application zone and the IO is the infrastructure services. So again, we're talking about networking, transport processing, storage in the sense of how storage is being provisioned and presented to the applications on top. We're talking about security, infrastructure management, protecting those applications running in that compute zone. So the driver here is that the complexity of these data center infrastructure workloads, communication, storage, security, these infrastructure services have become more and more complex over the years. And as such are imposing an increasingly burden, in terms of overhead on the CPU. And as a result, reducing performance of the applications. And really, moreover, having this sort of negative impact on overall data center efficiency. So you can find, articles that reference that these infrastructure services today can demand as much as 30% of your CPU cycles. And we believe that those compute cycles are really better served hosting the business applications. And in the end, I think this really sums up what drove the emergence of this DPU technology, right? And really, the core principles of the DPU, you'll hear me say it, over and over, but, offload, accelerate, isolate. So you're offloading those infrastructure services, you're moving, control plane and control plane policies off CPU on the DPU, you're leveraging hardware and a hardware accelerated data path. And just by the design of it, you're able to isolate the infrastructure domain from your tenant domain, and now thereby enhancing security, right? You're able to establish the foundation of that, quote unquote, zero trust security model, and delivering additional processing power so you can run more advanced distributed security services. So, this is kind of the way we think about the emergence of this technology and really the drive behind it.
Okay, that's awesome. And it maybe I'm not looking at this correctly, but it seems like there is a progression here. So we started with the NIC, been around for a long time. Then we then saw the smart NIC, and now today we're talking about DPUs. So are there particular aspects of the DPU that separate it from the smart NIC's capabilities?
Yeah, I'll give you my take on it, because I think, semantically wise, there's a lot of opinions on this, but I'll give you my take on it. For us, we have the ConnectX Smart NIC line, arguably the most advanced Smart NIC in the market, right? And that portfolio is really focused on data path acceleration. So when I talk about data path acceleration, I don't want to get too much into the weeds here, but it can mean, things like our ASAP squared, advanced switching and packet processing acceleration engine for OVS hardware acceleration. I could be referencing REMA engine supporting advanced Rocky workloads, or inline encryption for IPsec, TLS, or even more basic things like CRC or checksum or other transport offloads. So you think about a smart NIC was really focused on data path acceleration, these transport processing tasks that were running on hosts, but not very efficiently, and being able to do that in dedicated engines on the NIC, introduced greater efficiency, higher performance, and even lower latency. Now, for us, the way we differentiate to the DPU is really that the DPU is introducing, first of all, an array of general purpose processing elements, right? The programmable multi-core ARM array, right? So you've got this on there, and what that's doing is it's enabling the DPU to, not just accelerate the data path, but offload, some of the control path policies that are still running on host. So you're able to create more independence from your host, and that independence sort of plays into the third element, which is enhancing security, because now you can really create this air gap sort of architecture where you have your infrastructure completely air gap from your tenant domain. And that kind of rolls straight into that security story, right? Where now you've got this ability to have an independent domain for infrastructure that can't be breached by, say the tenant domain. And it also has these additional processing elements that allow you to run more advanced and distributed security services. So the ability to run that operating system, have the independence from the host, be able to air gap your infrastructure versus your workload domain. These are the things that really separate a DPU from a standard SmartNIC.
Awesome. Okay, that makes sense. Thanks for clarifying that. So shift gears a little bit here. I personally, my experience, often hear about people referring to HPC or high performance computing as a workload, but HPC it's actually a type of solution. It's supported and always will support simulation workloads, but HPC has also provided intense computation and data-driven approach that really bodes well for AI workloads. In fact, I can share, when I post this session, I will share a Dell reference architecture that illustrates that. Again, in my experience, organizations, they continue to move to, or they express an interest in this dedicated AI or multi-tenant AI cloud native environment. So with that said, can you speak to NVIDIA's cloud native supercomputing platform, and again, the value add that comes from the DPUs that are built in? And it seems like this supercomputing platform is more like a blueprint, basically, for, and simply put, HPC cloud experience.
Yeah, I mean, I would say HPC, scientific computing, and AI. Yeah, I mean, it's a great tee up. I mean, the introduction of the DPU, really allowed us to rethink the data center architecture. As I mentioned earlier, the unique capabilities of the DPU allow us to kind of take to heart this idea of offload, accelerate, and isolate of the infrastructure services, and we're freeing up compute to focus on these workloads or applications. And so when you think about what we've done with the cloud native supercomputing architectures, really we put the DPU kind of forefront as a critical or sort of disruptive technology, and we're leveraging the unique capabilities of the DPU to basically solve problems that we could otherwise not solve. And today it's really focused in, I think it's 5 areas, right? Maybe 4, it might be 6, but let me talk through them here. So number one, it's this idea of enhanced in-networking computing. So an example here is that we're offloading, collective communication libraries. So things like MPI for HPC, nickel operations for AI, we're offloading that to the DPU so we can realize the performance and I would say not only the performance, but the efficiency benefits that overlapping compute and communication operations can deliver, right? So the idea of non-blocking collective operations is not really new, right? This was introduced years ago, but the practicality of running these operations in parallel on CPU alone had resulted in kind of worse performance. And so now you've got the DPU, this processing element sitting on the data path. It's finally making this concept viable, right? So you're able to kind of run in parallel your compute operations and your communications operations. So with this, I guess we call it overlapping. You can think of it as parallelization, but the DPU literally, in addition to this, you can think of it as it's being able to offload the entire data exchange operations between nodes. So it's taking on the communications role kind of completely independent from host while providing sort of full transport processing acceleration. So essentially, you talked about the DPU being a server within a server. So here you have the DPU, it can independently notify and ultimately acknowledge the receipt of data, from neighboring CPUs or neighboring nodes. So essentially you're eliminating wait cycles, you're reducing application runtime, and ultimately further improving application performance. And in this case, there's work being done by Ohio State, by Georgia Tech, and others, and they're seeing like really significant application performance improvements. I'm talking about 20 to 30% type performance improvements. So it's really exciting stuff. So that's kind of the first element. Yeah. Let me pause there because I was mumbling a bit, but I said there's 5. So that's the first, and that's in networking computing. You want me to kind of go into the next few?
Yeah,
Yeah, so you've got the enhanced in networking computing. There's another area, computational storage, right? And this is things like compression, decompression, NVMe and file system offload, storage checksums, etc. Like if you're designing an accelerated JBOF, it's great. But what's maybe not so obvious is leveraging the DPU to address storage file system jitters. So if you take like VirtIOFS as an example, we can leverage DPU and move the file system operations from host to DPU. And this is like bringing another 20%. And even some cases, depending on what we are testing, we're seeing performance improvements up to 2x, so 20% to 2x in terms of eliminating file system jitter. So that's number 2. The third piece is something we call adaptive performance isolation, right? And this is really interesting, again, because we're talking about unique capabilities of the DPU to solve kind of problems that we are otherwise having trouble solving. And so this idea of adaptive performance isolation is the ability to control injection rates on the fabric, right? Ensuring that one application is not going to impact another application's performance. And it can be applicable to multi-tenant or even multiple users just running applications on the same infrastructure. And so we're able to kind of leverage the DPU and the DPU, telemetry services, and through that, the algorithm's going to collect the telemetry data. The data will be analyzed. Parameters will be updated dynamically. New policies will be set. And just like the name implies, you get this adaptive performance isolation. You're able to maintain predictability of application performance when there's a multi-tenant or multi-users sharing the same infrastructure. So that was 3.
So let me ask you a quick question there, if I can.
Yeah, please shoot.
Sorry,
go ahead.
Yeah. So you mentioned multi-tenant. So I'm assuming this is what this whole approach, this whole supercomputing platform, cloud native approach, it's not exclusively multi-tenant, right? It's not exclusively multi-tenant, and it's not just for the large enterprise deployments. Am I accurate?
Yeah, you're 100% accurate. And the name, I could get into it, but the name is kind of a more legacy artifact. The solution, the cloud native supercomputing solution has grown and expanded since its inception, which was really based on security. Like when cloud native supercomputing sort of architecture was being developed initially, it was sort of, we were looking at how the DPU is being used in the enterprise, and we said, you know what, this is a way to introduce enterprise class cloud-like security to HPC environments where, traditionally the security, policies were like a PDF of do's and don'ts. And we thought, hey, we can bring, kind of next generation class security to multi-tenant HPC. And, I said there was 5 elements. So that security, that's one of them, right? But what happened was, that's sort of where the focus was originally. But and there was a handful of customers that were kind of in the middle of a multi-tenant sort of HPC's deployments, and this meant a lot to them. But the more we explored the rocks that our customers were trying to break in this space, and kind of contrasted that to the capabilities of DPU, so the whole thing expanded, right? And so and that's when the next thing ended up being the in-networking computing, and then it was the computational storage, then it was the adaptive performance isolation, and it was the security was still kind of a foundational piece. And then, the final piece sort of in that, five areas that we're leveraging DPU here is also sort of leverages those telemetry services, right? It's something that, let's call it here smart scheduling, right? And today, from a scheduling, job scheduling perspective, it's not overly sophisticated, right? You have jobs, the job needs X number of servers, you have X number of servers available, so this is where you place the job.
Mm-hmm.
But, not only do we have the DPU, but we had this acquisition of Bright Computing, and now we can sort of correlate the job with the IO the job generates. So we can deliver information to the scheduler, which can use that data to consider, CPU, GPU, and IO requirements, right, before they place the job.
Mm-hmm.
So we can now kind of apply this greater intelligence to help determine the optimal place to place that job. Is it a heavy IO job? Is it a light IO job? And you can take that under consideration when scheduling. So that's kind of those elements, right? I mean, and I guess that was 5, right? It's the in-networking computing, your computational storage, your performance isolation, your smart scheduling, and then finally, where it all started was security.
Perfect. Yeah, and we've worked with NVIDIA to help customers deploy this type of supercomputing blueprint in their environments. We've also got, I should call out too, we've also got at Dell the latest NVIDIA DPUs available for configurations across multiple platforms. And I think we're also, I know I've talked to some within our group, and we should be releasing some validated architectures, which also include validated architectures for AI workloads that include DPUs. So a lot of exciting things around DPUs. This cloud native supercomputing platform it's really cool. Thanks for explaining that. So it's actually 6, not 5 key points, right? You said did you say there was a 6th?
I think that was 5, right? I think it's the in-networking computing, the computational storage, the performance isolation, the scheduling, and security. So,
got it. Okay, I thought I heard 6, so 5 is awesome too.
There was a lot of sub bullets there, yeah. But I agree with you. Dell's been a great partner for us on DPUs. They leaned in early. We kicked off multiple projects. We rolled out solutions that could be configured with DPUs, the second half of last year. We've got a nice roadmap in front of us. The collaboration between the two companies has been really tremendous in terms of them leaning in, or you leaning into new technologies like the DPU, and really seeing the benefit and value to your customers. So yeah, we're really excited about the work we've done with Dell till now, and even probably more excited about what we're going to do the first half of this year.
Yeah, I'm actually talking to a different NVIDIA team about Morpheus, and I think aren't DPUs part of NVIDIA's Morpheus AI cybersecurity framework, or at least
that's right.
I mean, some of the use cases.
Yeah, I talked about 2 of those use cases that really leverage what we call the DOCA telemetry services. And yeah, so this ability to leverage these sophisticated telemetry services within the DPU can play a really interesting role into the Morpheus solution.
Yeah, that's exciting. More to come there, I know.
Yeah.
So I think we're going to shift to a fun question now. So
right,
enough shop talk.
All right.
When Garth Fruge is not elbows deep in DPU stuff, what is your favorite thing to do? I mean, this could be a weekend thing to do, vacation, if you're into cliff diving, love to hear about that.
Yeah, well, so I've got 2 boys, 16 and 13. And so I'm usually hanging with them doing something. But we just got back from a snowboard trip, which was one of our favorite things to do as a family. But, you know, being from Texas, it always sort of surprises people. You know, my favorite probably two things to do with the family are snowboard trips and surf trips. And kind of that's what we
That's
do.
awesome.
That's what we live for. Yeah. And those are the things, that's how I like to try to occupy my free time.
That's fantastic. It can't think of a better way to do it. I agree.
Yeah.
The
Yeah.
surfing part, at least. I had my first surfing experience this past year,
Oh, wow.
and yeah, it took me probably about an hour, but I finally got up, and that experience when I was riding a wave, that was the aha moment for me when I said, now I get the addiction to this.
Yeah, it's hard to explain, but in those moments, you know, you get those are the moments that keep you coming back, right? So
Oh yeah,
yeah, that's cool to hear. Where were you?
in Costa Rica.
Oh, perfect.
Yeah.
Yeah, I was actually married on a beach in Costa Rica. We've done a lot of trips down there since.
Oh, I
So
love it. Yeah.
yeah, yeah, we love that place as well.
Well, this has been awesome. Fantastic discussion and insight, Garth. Thank you for your time. And thank you all out there for taking time to join the session. And please check back for future sessions as we find another smart person to help us explore this wildly fascinating AI ecosystem. Cheers.
Thanks, Mark.